We are talking about graphing quadratic inequalities, and we want to graph systems of quadratic inequalities. So we have the inequality y is greater than x squared minus 3, and we want to be able to graph that. This is in Vertex Form, so right away we know that the a value is equal to 1. We know that the vertex, because there's nothing written next to the x, we know that the x value is 0, and we know that the k value is negative 3. So we have 0 and negative 3 as the vertex, and we have x equals 0 as the axis of symmetry. So we can get a few points. We know that the vertex is 0, negative 3, so we can plot that. And when we plot that, we need to have, we need to count by 2's. So 2, 4, 6, 8, 2, 4, 6, 8, 2, negative 4, negative 6, negative 8, negative 2, negative 4, negative 6, negative 8. And we know that we have the point 0, negative 3. So 0, negative 3. Because the a value is 1, it's going to be the same as the parent function. So we go to the right 1, we go up 1. So that is going to be 1, negative 2. If we go to the right 2, we go up 4. 1, 2, 3, 4. So that is going to be the point 2, 1. And negative 1, negative 2. Because we go over 1, back 1. And negative 2, positive 1. We can get one more good point. If we go over 3, we should go up 9. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. 1, 2, 3. This is not equal to, so we know that we have to have a dashed line. So we can draw a dashed line that goes through those points. And then we have to check where to shade, and I'm going to check 0, 0. And we can substitute that in. So 0 is greater than 0 squared minus 3. 0 squared is 0, so 0 is greater than negative 3, and that is true. So for this graph, we're going to shade above. Then we can take a look at our other inequality. And for this one, we need to be able to use our axis of symmetry, which is x equals the negative stays, the divide sign stays, and the 2 stays. Then we need the a value, which in this case, a is equal to negative 2. Then we need the b value, which in this case, b is equal to 4. And we need the c value, which in this case, c is equal to 5. So we can substitute those values in. So the negative stays, the divide sign stays, and the 2 stays. The a value is negative 2. And the b value is 4. So then we get x equals -4 over -4, which is equal to 1. So the axis of symmetry is x equals 1. So we can go ahead and graph that. Halfway between the y-axis and 2. So this is x equals 1. And then we have to calculate where our vertex will be located. So we can substitute x equals 1 back into the equation, or back into the inequality. So we get y is less than -2 squared plus 4 plus 5. And then we're going to substitute the 1 in. So we get y is less than 1 squared is 1 times -2 is -2 plus 4 plus 5. And then we get our vertex is y is less than 7. So our vertex is the ordered pair 1, 7. So we can get a table. So we can put xy right here. And we know that our vertex is 1, 7. So I can graph that over 1 up 7. And our a value is -2. So if we go to the right 1, so to the right 1 from here is 2. And then we have to go down 2. So then we go to 5. Right 1, down 2, 1, 2. And then we go to the right 2, which puts us at 3. So 1, 2, and then we go down 4. 1, 2. Then we go down 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So that puts us at 3, -1. And then we can reflect these over 1, 2, 1, 2, 1, 1. And it just so happens that our C value is 5, and that also goes through at the y-axis of 0, 5. This is a dashed line, so we can draw a dashed parabola. And we can draw a dashed parabola that goes through those points. And then we know that we did check 0, 0 for this one, so we should shade this way. And then we should check 0, 0 for this other one. I should write down these other points. So we did have 0, 5. And then we also had -1, -1. And then we can check, and we want to check 0, 0 again. We're checking 0, 0 for our shade. And we can substitute in 0. So 0 is less than -2 times 0 squared plus 4 times 0 plus 5. 0 squared is 0 times -2 is still 0. 4 times 0 is 0. So these are gone. And we're just left with 0 is less than +5. And that is true. So for both regions, we want to shade inside the parabola. So we want to shade that region there. and that is our solution set.